So let's answer our starter questions here quickly. Okay, and again, this is just review from what we did last time, right? To be able to identify each conic section, okay? Because on a test, I guarantee you, because I just finished writing it this morning, you're gonna be given equations and just asked to identify which conic section it is, okay? So if it has one squared variable, what is it? It's a parabola, correct. If it has two squared variables and they have the same sign and the same coefficient, that is a circle. Yep. If they have the same sign and different coefficients, it's an ellipse, and we are going to talk about those today. Other than circles, ellipses are probably the easiest conic sections to deal with, okay? And then if it has different signs, then it's good. All right, so now the equation for an ellipse, okay, like all the other conic sections, comes from a definition. All right, so an ellipse is a set of points on a plane, the sum of whose distance from two fixed points is constant. Thank you. And the two fixed points are called, anybody know? It's the plural for focus. Which you would say foci.
Really?
Okay.
Why is
Yes.
it guys like fungus? Is
Yep,
foci?
it's not focuses, it's foci.
So it's
It's not octopuses, it's octopi, right? There you go. There you go. It's true. It is a true statement. All right, so now we know from the previous section that ellipses have two squared variables that have the same, what? Same sign, but different coefficients. Okay? And just like circles and parabolas, the graph-friendly form of the ellipse, okay, contains perfect squares. Okay, so for example, we have our circle there, x minus 2 squared plus y plus 1 squared equals 4. So, where's the center of that circle, by the way?
0, 0?
No, of this circle right here. Where's the center? Center's at 2 and negative 1, and what's the length of my radius? 2. Good. Okay? All right, so our parabola, where's the vertex of that parabola? Vertex is at,
2, negative 1.
look closely, at negative 1 and 2, right? Always got to go with the x first. And on parabola, the x's and y's are switched. Okay, so it's at negative 1 and 2. And what is a? What's the distance from my vertex to my focus? A is what? Good. A is 2. Because remember, this number oops, that number that I just missed on. This number equals 4a. Okay? All right, so now the equation of an ellipse in graph-friendly form, okay, looks like this one in example 1a here. Okay? So let's fill out our little box, and then we'll start doing some problems. So we have x squared over a squared plus y squared over b squared equals 1. Is that an ellipse with the center's at the origin here, right? Because there's no h and k. Just like in a circle or like in a parabola. Okay, it's the same with an ellipse, and the same is going to be for hyperbolas as well. Okay, so it centers at h and k. Now from the center we go a units in the x direction and b excuse me, b units in the y direction. The major axis is determined by whichever is bigger out of a and b. Gosh, sorry, something caught my throat. Now, the foci are always located on the major axis. So in an ellipse, the major axis is always the bigger one. The minor axis is the smaller one, and the foci are always on that bigger axis. Always, 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 always. Okay? And then the foci are what we call C units from the center. Okay? All again, along the major axis. Now, this is an important one, this formula here. Okay? A squared minus b squared equals c squared. We use that to find c. Okay? Yeah, it's a little like the Pythagorean theorem, huh?
What is it?
Pythagorean theorem for real is a squared plus b squared equals c squared. Okay? So this is a little different, okay? Now, just remember, so and then the little parentheses is kind of a good little hint to help you, because we're gonna have a formula similar to this when we do hyperbolas, but it's not exactly the same. So you've gotta be able to differentiate between the two of them, okay? So for, ellipses, okay, it's the big one squared minus the little one squared equals c squared. Okay? All right, so now in an ellipse, never forget that a squared is always the big one. Okay? All right, so let's go ahead and do example 1a here. All right, so I have x squared over 25 plus y squared over 9. Okay? So I'm going to go how far in the x direction? Well, first of all, where's the center? Let's do that first. Center's at the origin, right? Center's at 0, 0. Now, how far each way am I going to go in the x direction from the center?
25.
Okay, that's a squared, so I'm going to go 5, because 25 is a squared. So I go 1, 2, 3, 4, 5, put a point, and then 5 the other way.
Scroll down.
What are you talking about? It's on A. LOL.
So the x-axis is the major axis.
What's that? Yeah, so in this case, yeah, the x-axis is the major axis on our ellipse. Now, how far do we go in the y direction? We go 3 in the y direction. So we go up 3 and down 3, and that is your minor axis. Now, you just, a nice smooth curve without drinking alcohol before. No, I'm kidding. I don't drink. Just don't want to have that known, because that just got recorded. So anyway, okay, and there's your ellipse. Now let me ask you this: what is the length of the major axis? 10. Good. The major axis goes from ellipse to ellipse, through the center, from the ellipse to the ellipse. So what's the length of the minor axis? 6. Good. Now let's find where our foci are. Okay. Now, in an ellipse, these 2 points right here on the major axis are sometimes called the vertices. You won't see that all the time, but if you do, if it asks for vertices of an ellipse, that's what it's talking about. So what are the coordinates of those vertices there? 5, 0, and -5, 0, right? That's where those are. Now, sometimes it'll ask for these points here even as well. So we're at 0, 3, and 0, -3 for those points. But now we're going to use our equation there to find where our foci are. So we're going to go a squared, which is, what's a squared? 25, minus b squared, which is 9, and that equals c squared. 25 minus 9 is 16, is c squared, so c is 4. Now again, c is the distance from the center to the foci. So where are my foci then? They are right here and right here, because the foci are always along the major axis. Okay.
Why do you need to know the foci?
Because you don't need them to graph it, but the foci are an integral part of the definition. It's just like a parabola, right? We never needed the parabola or the directrix to graph it, but we needed them for the definition. Okay? Because here's, and let me just show you now graphically, here's what the definition of an ellipse is. Okay? It's a set of all points such that the sum of those points are, or the sum of the, gosh, I can't even talk now. Let's try this again, shall we? Okay, it is a set of all points, okay, such that the sum from the foci is always equal. So in other words, if I take this distance plus that distance, okay, that's going to equal, let's pick this point here, this distance plus this distance. Or if I pick a point right here, this distance plus this distance, okay? That's how you come up officially with an ellipse, okay? It's just those set of all those points, okay? So that's why we need the foci. So in this case, the coordinates of my foci are plus and minus 4 and 0, right? 4 and 0, and then -4 and 0. That would be your foci. Okay. All right, let's try another one here. All right, so part B now. Okay. Now, you know what? Let's fill out the box first. Okay. So now we have x minus 1 squared over 9 plus y plus 1 squared over 25 equals 1. So now where's the center of this ellipse? Where do you think? At 1, -1. Good. Right? Rules are the same, just like for ellipses, parabolas, circles, all that stuff. It's all the same. Okay, now it says look at the number under the x squared term. Take the square root, then go that many units in the x direction from the center of the ellipse, not from the origin now, because the center's not the origin. You always go from the center, okay? And then same thing in the y direction, okay? So let's go ahead and do that now, and then we'll answer the rest of this. So let's plot our center at 1, -1. All right, so the center's at 1, -1. There's our center. Now from here I go how far in the x direction? 3. So I go 1, 2, 3, and 1, 2, 3.
Wait, why are we doing that?
What?
Don't you choose the bigger of the two?
Well, I've got to do them both sometimes.
Goes on the X and
But x still goes with the x, y still goes with the y,
Okay, yeah.
right? So now with the y, how far do I go? I go up, yeah, so we go up 5. 1, 2, 3, 4, 5. And we go down 5. 1, 2, 3, 4, and 5 right here. Okay? So here's what our ellipse looks like now. Like a big old fat egg, apparently. All right, so now, where is my major axis? Is it horizontal or vertical? It is vertical. Okay, major axis is always the bigger one. Now what's the length of my major axis? It's 10. What's the length of my minor axis? 6. Good. Okay. Now if I wanted the coordinates of my two vertices here, what would they be? So we know the center's at 1, -1. Where are those two vertices? They're at 1 and what? 1 and 4, and 1 and -6. Good. Okay. All right, now we need to find, cancel. I need to get a palm guard on this. Okay, now we need to find the coordinates of our foci. Okay, so again, we do, now in this case, okay, because the bigger number's under the y, that is a squared. And this is b squared. So our foci, okay, is going to be the same thing. 25 minus 9 equals c squared, so c is 4. So now from the center, where do I go?
Wait, why is 1 -4? Oh,
Because that's the, it's not.
The bigger number is always A, so
Yeah, bigger number's always a.
we lost you. You got two free movie tickets though.
All right, so now our foci then, so we figured out c is 4. So then our foci, we go up 4 and down 4 from the middle. So our foci are then at 1 and 3.
Is it always going to be one away?
No. And 1 and -5. No, it just happened because we had the same A and B on both those, but no, it won't always be one away. And it depends on, Larissa, it depends on how far apart A and B are. Okay, if they're really close together, then it's going to be closer to a circle, so your foci are going to be in a lot closer. Okay, Austin, I'm trying to talk to her. Shut up. Quit bugging. Quit bugging. Okay? The farther apart A and B are numerically, okay, the more oval.
A and B. Oh, 9 and 5.
Right. The bigger discrepancy there are between those, okay, the more oval-like your ellipse is going to be. The closer they are together, the more circle-like the ellipse is going to look, okay? And you'll see that as we do a bunch more problems here.
Thank you.
All right, so let's just finish this box here. All right, so we look number into the x squared term, take the square root of that. That's how far we go from the center. Number into the y squared term, we all know that. Okay, now the major axis is the longer one. So in this case, the major axis runs
Up and down.
vertical.
Up and down.
Okay, and we already did the length of the major axis was 10, and the length of the minor axis was 6. Oops, 6. Okay, and then the foci are C units from the center, and so C, we did C equals 4. Good. Okay. Okay, so let's want to graph this and then label our important parts. This means we want our vertices and our foci, basically. Okay? All right, so center. Center's where here? 0, 0. Good. It's at the origin. Okay, now in the x direction I go 3, right? So b is 3 basically, because that's the smaller number. And in the y direction I go 4. Okay, so there's the ellipse. Okay, and you can see 9 and 16 a little closer, Larissa, that's a little more circular. Though it looks like a balloon, but anyway, you get it, right? So to find our foci then, we take a squared, big one, minus the little one, equals c squared. So now in this case, c is the square root of 7. Okay? So, now if we want to find the exact points for our foci, okay, oh, we didn't even do our vertices yet, sorry. So let's do our 2 vertices. So where are our vertices? They're where? Which one's the major axis? Horizontal or vertical? It's vertical, so where are the vertices then? At 0 and 4 and 0 and -4. Good. Okay. Now let's find our foci. So if c is the square root of 7, then our foci are at 0 and root 7 and 0 and -7. Okay, so square root of 7, let's see, square root of 9 is 3, square root of 4 is 2, so it's roughly 2.4-ish. No, probably closer to 2.6, 2.7-ish. So come up 1, 2, and again, Larissa, so now you can see how the foci are farther from the vertices here. Again, because A and B are closer together. Okay?
What does the foci do again? Like, why do we have to do that?
That's the definite, because that defines an ellipse. It's a set of all points whose sum is constant or sum is the same from the 2 foci. So if I pick any point on the ellipse, in other words, okay, and I add the distance from one focus to the distance from another focus, it will always be the same, no matter where I pick on the ellipse. If I picked right here, that plus that would also equal the same thing. Okay. Okay. Yep. Center's at 0, 0. Right. Major axis, horizontal or vertical? Horizontal. So how far in the x direction? 5. So my vertices are at 5 and 0 and -5 and 0. Okay. Then in the y direction I go up 2 and down 2. So again, now you can see that this is more ovalish as A and B get farther apart. Okay, so then C is equal to the square root of 25 minus 4 or the square root of 21. Okay, so officially my foci are at root 21 and 0 and negative root 21 and 0. Okay, and square root of 21, that's 4 and some change, right? Square root of 16 is 4, square root of 25 is 5, so it's about 4.6, give or take. So right around in there and there, okay? And there, again, the foci are getting very close to the vertices. All right, we okay with that? All right, so part C, major axis, horizontal or vertical? Vertical, correct. Okay, so we go how much in the y direction then? Let's do that major axis first. 4. And those are our vertices. So we know the center's at the origin. No, it's not. Man, you guys got to correct me on that.
We're just going to.
Yeah, whatever. I was just about to.
Well, I already put the dot on my paper.
Nice. So where's this? Oh my gosh. Okay, let's erase all this and start over. All right, so where's the center here, sports fans? At 2, -1. Okay. All right, now, so we know in the y direction we go up and down 4. So we go up 1, 2, 3, 4, and down 1, 2, 3, 4. All right, so where are our vertices then? 2 and 3 and 2 and negative 5. Okay. All right, now how far do we go in the horizontal direction? Root 7, right? Which is 2 and some change, like 2.6, 2.7.
No question.
Okay. So we go 1, 2 and some change. 1, 2 and some change. And there's our ellipse. Okay. All right, let's find our foci. So c squared equals 16 minus 7. 16 minus 7 is 9. So c is 3. So I go which way now from the center? Up and down. Good. So I go up 1, 2, 3 and down 1, 2, 3. So where are my foci then? 2 and 2, and then 2 and negative 4. Questions?
Oh,
So what do we have to do here on example 3, part A first?
Put it in the graph.
Right, our graph-friendly form. So what does that mean? It's got to be, yeah, we got to divide by 8. Good, Tyler. We got to set it equal to 1, right? So we divide everything by 8, and then we're ready. So we get y squared over 2 plus x squared over 8 equals 1. Whew. Okay, major axis, horizontal, vertical. Major axis is horizontal. Oh, and you know what? And we should probably actually just change the order, right? So, because we usually always have the x first, but if we don't, in an ellipse it doesn't matter. Now, when we talk about hyperbolas next week, order's going to matter because one's positive, one's negative. But for ellipses, it doesn't matter. Okay, so we know we're going to go. So in this case, a is the square root of 8, b is the square root of 2, and we can figure out c real quick if you want. All right, c squared is 8 minus 2, or c is the square root of 6. Okay. All right, center, 0, 0. All right, so in the x direction, we go root 8, which is almost 3. Okay. Now, so where are our vertices then? At root 8 and 0, and negative root 8 and 0. Okay, b, we go root 2, which is 1 and some change. Okay, and there's the ellipse. Okay, we know c is root 6, so we go root 6 is a little more than 2. So then our foci are at root 6 and 0, and negative root 6 and 0. We good? Okay. So part B now, we've got to do what? Our favorite thing, we've got to complete the square.
all right.
Let's call it big.
Yeah, buddy. All right, we give you some easy ones here. So we get 4x squared plus 8x. Okay, and then we're going to get something else in there, and then we've got plus 3y squared minus 6y equals, equals 5. All right, so first step. We've got to factor out, right? We've got to factor out a GCF because we can't have a leading coefficient that's not 1 to complete the square. So we're going to factor out a 4 with the x's here, and I'm left with x squared plus 2x plus something something. I'm going to factor out a 3 here, so then I get y squared minus 2y plus something something equals 5. All right, so now let's complete the square. So half of 2 is 1. And remember, we write that down because we're going to need that in a second. 1 squared is 1. So if I add a 1 right there, what do I add on the left side? No. No. What do I add? I added 1 in here, but what did I really add? 1 times 4. So we got to add 4 over here. Okay. All right, so now let's go with our y's here. So half of minus 2 is minus 1. Minus 1 squared is 1, but what am I adding? 3. Very good. Okay, so now for my x's, I get 4 times x plus 1 squared. Again, that's why we write that down. Plus 3 times y minus 1. Oh, gosh, I already wrote that. Hello. Y minus 1 squared equals 12. Okay? Next step, divide by 12. Yeah. So then we get, I'm going to write over here on the right-hand side. So we get x plus 1 squared over 3 plus y minus 1 squared over 4 equals 1. Now we're ready to roll. Okay. Now we're in our graph-friendly form. Okay. So, major axis, horizontal, vertical. It is vertical, correct. Okay. So, in this case, A is, what's A? 2. What's B? Root 3. Let's find C. Okay, so C squared is 4 minus 3.
I thought A was with the X.
No, A is always the bigger one. Always, 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 always. A is always bigger. Okay? Now, with the hyperbola, Larissa, you're right. A is always going to be with X. But for ellipses, A is always bigger. So what's C in this case? So, yeah, C is just 1. Okay, now we're ready to roll. Where's the center? At negative 1 and 1. Good. And that's everything, right? So here's our center. So, and then A we decided was vertical, correct? So we go up 2 and down 2. There's our vertices. So now our vertices are at negative 1 and 3 and negative 1 and negative 1. Okay, we go root 3 in the x direction. So that's 1 and some change. 1 and some change. And there's our graph. Okay. And then our foci, we go in the vertical direction, up 1, down 1. So now the coordinates of our foci then are negative 1 and 2 and negative 1 and 0. And there we go. So again, the closer A and B get, the more circle-ish it looks. Okay, so first of all, if our center's at the origin, then we know we're at x squared over something plus y squared over something equals 1. Correct? Now we've got to figure out our somethings, right? So what do we know? So we know one focus is at 0 and 2. So what does that mean A is?
2.
A is 2. No, that's wrong. What do we know C is? Because it's a focus. We know C is 2. Now we know the vertices are at plus and minus 3. 0 and plus minus 3. So what is A? A is 3. Now we just got to figure out B, and we're golden. Now, which way is our major axis? Vertical, horizontal? It is vertical, correct? Because look where your vertices are. Center's here. Vertices are at 0 and 3 and 0 and negative 3. One focus is at 0 and 2, which means where's your other focus? 0, negative 2. Good. So now we've got to figure out B. So we already know that's 9 because that's A squared, right? Now we just got to figure out B. And how do we figure out B? What's the formula? A squared minus B squared equals C squared, right? So we get 9 minus B squared equals 4 So we get negative b squared is negative 5, and b is the square root of 5. So where are the vertices then? Well, first of all, what number goes under x squared?
5.
Yeah, it's 5. Good. Good, Hayden. Okay, and where are our foci? We don't need them, but I just want you to get used to it. Good. Okay, so now we go root 5 in that direction, which is 2 and a little bit. And there's our ellipse. Looks like a walnut, right? Because it's not, because walnuts aren't very smooth on the outside. If you tip a walnut up and look at it, that's what that looks like. Okay, so this gets a little goofy, but we can handle this. All right, so our center's at 2, negative 3. Now, what does our equation look like then? X minus 2 squared plus y plus 3 squared, and those are over something, something, and that equals 1. Okay, so one focus is at 3, negative 3. So there's a focus. Now, what does that mean C is? If the center's at 2, negative 3, and the focus is at 3, negative 3, what's C?
2, 1.
1, good. Okay, now one vertex is at 5, negative 3. Okay, so what's A? I'll wait. What's A?
3.
Excellent. How'd you get that, Matt?
5 minus 2.
Yeah, it's just 5 minus 2, right? A is the distance from the center to the vertex. Okay, so again, we're left to find B. All right, so where is our, okay, so if this is our center here, center, focus, vertex. Okay, where's our other focus? If one is at 3, negative 3, where's our other focus? At 1, negative 3. Good. Where's our other vertex then?
Negative 1.
At negative 1, negative 3. Good. All right, so we know A is 3. Now, okay, major axis is obviously horizontal, so 9 goes here. Now we got to find B. So we get, again, A squared minus B squared equals C squared. So B squared is 8, and B is the square root of 8. Now in this case, leave it like that. Don't simplify that to 2 root 2. Okay? We want square root of 8. So that means there's an 8 under there. So we go up root 8. 1, 2, almost 3. And down root 8. So again, foci are closer to the center, very circle-ish. Albeit an abnormal circle, but anyway. Questions? Okay, we kind of alluded to this already, but what are the similarities between the equation of an ellipse and the equation of a circle? So what's similar about them? They both have how many squared terms? 2 squared terms. The signs are the same. Yeah, the signs are both positive, right? Okay. What is the difference? In an ellipse, we have A and B. In a circle, we just have R, right? Or A or B. The A and B are the same. Okay. In an ellipse, A and B are different because you don't have a constant radius, but in a circle, it's all the same. Okay. All right. Any questions? I believe that does us.